Hey everyone, welcome back to the College Algebra playlist. In the previous videos, we took a look at polynomials, and we showed how to add, subtract, and multiply polynomials. Okay, so in this video, I want to take what we've learned and apply it to some concrete examples. All right, so let's work through some problems right now. Okay, here we go. Example 24. Here we're asked to add the polynomials. All right, so we have 4x cubed plus 8x squared minus x plus negative 2x squared plus x plus 6. The first thing we want to do is get rid of these unnecessary parentheses. Okay, so because there's addition happening here, we can just get rid of those parentheses, no problem. All right, it's not as simple when we subtract polynomials. All right, that's coming up next. But for now, we're adding, so we just get rid of the parentheses, and we can see our next step is going to be to add like terms. All right, we need to add like terms to condense this thing down into a simpler expression. Okay? 4x cubed, we'll start there. Okay, that's going to be my leading term. Right, the highest power is 3 in this expression. All right. So here in blue, I have 8x squared and negative 2x squared, right? Those are like terms. So we're going to add those together. And then here in red, I have negative x and positive x. Those are like terms, so we're going to add those together. And lastly, I just have this 6 floating around. There aren't any other constants, so we're just going to tack this plus 6 here onto the end. Okay? Next, we simplify the business in parentheses, right? 8x squared minus 2x squared is 6x squared. Okay? And then here in this set of parentheses, the minus x and the positive x, they cancel each other out additively, and they just leave us with 0. Okay? So next we get rid of the parentheses, and we report our final answer as 4x cubed plus 6x squared plus 6. Okay, here we're asked to subtract the polynomials. Okay? So we need to get rid of these parentheses, but it's not as easy this time. Okay? When I subtract this entire trinomial here on the right, when I subtract that, that is the same thing as multiplying the whole thing by negative 1. Okay? So we're going to distribute this minus 1 to each piece of the trinomial. Okay? So let's do that right now. We get minus 3y squared plus 6y, right? A negative times a negative is a positive. Okay? And then we get negative 1 times 3, right? That's negative 3. Okay? So we successfully got rid of the parentheses. Okay, next we need to add like terms. So here in blue, I have 6y squared and negative 3y squared. Those are like terms. And then here in red, I have 24y and 6y. Those are like terms. And then here I have 24 and negative 3. We're going to add those together, right? Those are our constants that are floating around. Okay? Next step, we need to clean up the business in parentheses, right? 6y squared minus 3y squared, that gives me 3y squared. And then here, 24y plus 6y gives me 30y. And here, 24 minus 3 gives me 21. So those parentheses are no longer necessary. So we're going to get rid of those. And we'll report our final answer as 3y squared plus 30y plus 21. Okay, here we're asked to multiply the binomials. All right, so whenever we have something that looks like this, we need to use FOIL to get rid of the parentheses. Okay? So using FOIL, my firsts are 4x and 6x. Okay, so that product is 24x squared. My outers are 4x and negative 4. Right, so that product is negative 16x. My inners here in green are 2 and 6x. Right, so that product is 12x. And my lasts in orange are 2 and negative 4. Right, so that product is negative 8. Okay? Next, we need to add like terms. Right? We can see that here in blue, negative 16x and 12x are like terms. So we're going to add those together to get negative 4x. Okay? So this is my final solution. 24x squared minus 4x minus 8. Okay, here we're asked to multiply the polynomials, but it's not as simple this time. Okay, I have a trinomial times a binomial here. All right, so remember my advice. My advice is that whenever there's more than two terms in a piece of the product here, right, if we have a trinomial, we need to use the box method. Okay, so that's what we're going to do right now. So remember, we're adding up the areas of each of these mini rectangles to get the area of the entire rectangle. All right. My first mini rectangle up here is the top left. Okay, so let's do 3w squared times w. That gives me 3w cubed in blue. Okay. Next I have negative 6w and w. Right, that product is negative 6w squared in red here. Okay. And then for this top right mini rectangle, right, I have 2 times w. Right, so that product is just 2w. For my bottom left mini rectangle, I have 3w squared times negative 4, which is negative 12w squared. And then for this mini rectangle, I have negative 6w times negative 4. That's going to give me positive 24w. Okay, and lastly, for this bottom right mini rectangle, I have 2 times negative 4. Okay, so that's negative 8. Okay, so we're going to add up each area of each mini rectangle. Okay, so that's what we have up here. All right, we don't need the rectangle anymore, so I'm going to get rid of it. All right, our next task is to add like terms. All right, so let's do that right now. My leading term is 3w cubed. Okay, and here I have negative 6w squared and negative 12w squared. Those are like terms, so we're going to add those up. And then here in red, I have 2w and 24w. We're going to add those up. And this negative 8 is just floating around. We're going to tack that onto the end here. All right, that minus 8 goes there. Okay, cleaning up the business in parentheses. All right, we have negative 6w squared minus 12w squared. That gives me negative 18w squared. And then here we have 2w plus 24w. That gives me 26w. Getting rid of the parentheses, we get 3w cubed minus 18w squared plus 26w minus 8. So that's my final answer. Okay, here we're asked to square the binomial. Okay, so we're going to do 4x plus 5 times 4x plus 5. All right, and that's going to give us a perfect square trinomial, right? This is the formula that we derived in a previous video, right? Okay, so let's use that right here. I have a equals 4x and b equals 5. All right. So the first thing we want to do is do a squared, right? So we get 4x squared. And I've just made a mistake here. All right, this is incorrect. All right, I'd like you to pause the video and ask yourself, what's wrong with this? Okay, why is this incorrect? I have a equals 4x. Okay, so if we're squaring a, we need to include parentheses here. All right, so we're going to square 4x here. All right, so we get 4x squared plus 2ab, right? So plus 2 times 4x times 5. And then plus b squared. So we're going to add 5 squared to this. All right. Getting rid of the parentheses here, we get 16x squared. Okay. And then this product right here, 2 times 4x times 5, that's going to give me 8x times 5, right? Which is 40x. All right. And then 5 squared is just 25. So this is our final answer, 16x squared plus 40x plus 25. Okay, so we used the formula to expand this thing instead of using FOIL, right? And it was faster. It's faster to do it this way. Okay, last example, we're going to multiply these binomials together. All right, and we could use FOIL to do that, or we could use our formula we derived. We have a plus b times a minus b equals a squared minus b squared, right? This is the difference of squares pattern. All right, so a equals 4y and b equals 2. All right. So we have a squared, right, which is 4y squared. Notice I'm including parentheses again to avoid the mistake from last time. All right, we need to square that entire thing. All right, the thing is 4y. So we have 4y squared minus 2 squared. All right, and that gives us 16y squared minus 4. So that's my final answer. That does it for this video. Thank you for watching, and like and subscribe.